Hey guys, in this problem, I'm going to teach you how to do the hypothesis test for proportions. This is the 2012 AP Statistics Free Response question that I'm using. So let's get to it. A survey organization conducted telephone interviews in 2008 in which 1,009 randomly selected adults in the U.S. responded to the following question. At the present time, do you think television commercials are an effective way to promote a new product? Of the 1,009 adults surveyed, 676 responded yes. In December 2007, 622 of the 1,020 randomly selected adults in the United States had responded yes to the same question. Do the data provide convincing evidence that the proportion of adults in the United States who would respond yes to the question changed from December 2007 to December 2008? Now, we are going to say this is a hypothesis test. I'll make alpha equal 0.05 anytime they don't give it to you. You're going to start with step one, which is HO and HA. We're going to do P1 is equal to P2, and P1 does not equal to P2. We said does not because the word changed. You have to define your parameter of interest, where P1 is equal to and P2 is equal to. So we need to use the word proportion in both cases, okay? Where P1 is the proportion of people who responded yes in 2007, and then P2 would be the 2008, okay? So I'm just gonna do that. There, you guys can fill this in so we can save some time. So make sure that you write perfectly the parameter of interest, where P1 is the proportion of people who responded yes in 2007, and P2 is the proportion of people who responded yes in 2008. So that's step one. Step two is our conditions. So in this problem, they told you it was random for each one of the 1,009 adults surveyed. Okay, so here was randomly selected, here was randomly selected. Anytime you're dealing with two populations, you must make sure that the conditions are satisfied for both populations. Now, one other thing that we need to consider here in order to do this is we have to basically assume that these 1,020 people are independent from the 1,009 people. In other words, no one really voted yes twice. So that's safe to assume. All right, so the stem of the problem here, the stem of the problem states that in both years, the adults who were surveyed were chosen randomly, And then you have to check all four of these, N1 P hat 1, N1 Q hat 1, N2 P hat 2, N2 Q hat 2. For those who don't remember what Q hat 1 is, that's 1 minus P hat 1. I know some college textbooks only use 1 minus P hat 1. I call it Q. So here we get 676, we get 333, we get 622, and 398. These are called successes and failures, okay? So 1,009 times 676 over 1,009. Constantly remind yourself that this N is a number, this P hat is a fraction, and so on. So the way you get the 333 is basically 676 minus 109 leaves you with 333. And 622 minus 120 leaves you with 398. So these are your four successes and failures. So I said, since the two successes and the two failures are both greater than 10, we can assume the distribution is approximately normal. So step two is satisfied. So step one was hypothesis, step two is conditions, step three is our formula. Now, I'm going to show you something a little bit different this time with the formula. We have, first and foremost, the Z, it's always Z, statistics minus parameter divided by the standard deviation of the statistic. We always say P hat 1 minus P hat 2, that's great. Then we always say minus 0 because of the hypothesis. But typically here we go P1 minus P2, and that's equal to 0. So we don't need that part. The bottom part, we typically use this, but This bottom part where this is P, right? This is P, this is Q for sample 1, and this is P and this is Q for sample 2. You're only supposed to use this if the proportions are not equal, or the difference in the proportions are not equal to 0. So if you said, hey, we think the difference in the proportions is 15%, then we should use this, okay? If we say that we think the difference in the proportions of people who survive using an injection treatment as opposed to a pill is 0.02, then we use this. But because in most cases we end up using, we assume P1 equals P2, your denominator has to be this guy here. Okay, so what is this guy here? Well, this is P hat of C. P hat of C is basically you take the two x values and add them together, right? And you take the two n values and add them together, and then you divide. So in this case, you would take basically 676 and 622, and then I'm going to show you on the next page. Then you take 1009 and 1020. It's not like you're adding regular fractions where you need to find the common denominator. So you add the numerators, you add the denominators, and that's your P hat of C. So let me start by showing you this. So let's leave the formula as is. This here is in your formula sheet. It says when P1 is equal to P2, this should be in the denominator, okay? So I'm going to press test, stat, test. I'm going to go down to 2 prop Z test. I'm going to put my numbers in, and then I'm going to hit does not equal. I'm going to hit calculate. After I hit calculate, I get all of these values. This value here is my z-score. Great. This value here is my p-value. Great. Next one here is if I took the 676 and divided it by 1009, I would get this number. If I took the 622 over 1020, I hope those numbers are right, but you know what I mean. If I took the p hat 1 and divided it, I would get this number. And if I took p hat 2 and divided it, I would get this number. This number here, 0.6397, is this here. So the 0.6397 is going to be just this guy there. 1 minus that number would be there. 1 over n1, 1 over n2. So let's see. I have my 676 over 1009. It was right down here anyway. So let me get my yellow highlighter. P hat 1 minus P hat 2. That's these guys. Okay, or this guy here. Divided by square root of P hat C, 1 minus P hat C. So if you take 0.6397 and add it to 0.3603, you get 1 whole. 1 divided by n1 plus 1 divided by n2. So technically, your denominator cannot be P hat 1 times Q hat 1 over n1 plus P hat 2 times Q hat 2 over n2. This is the only case ever, only for a 2-sample proportion, where we have to fix our bottom part of it, okay? So this is how we do it. I'm going to do another video right after this to show it again. But P hat 1 minus P hat 2 divided by the square root of this special P, right? This P can be found by taking the numerators, adding them up, taking the denominators, adding them up, and then getting that answer. So I showed it here, okay? I showed it somewhere. I guess I didn't put it into the lesson, but that's okay. If you took your calculator and did this, you would get this guy right here, okay? So I just put that there, and I put 1 minus it right there, and then 1 over n1 plus 1 over n2. To be quite honest with you, this is the right way of doing it, but if you did p hat 1, q hat 1 over n1, I'm not sure if they would take off points or not. So I recommend you just remember this. Use your formula sheet. All right, p-value. P-value is this guy here, right? 0.0047. So the z-score was positive, so your arrow should be pointing up. P times the P of z is greater than 2.82, 0.047. You have to put the 2 in front of there if you want it to be correct because it's a two-sided test. This is very small. Assuming HO is true, since the p-value is less than 0.05, we reject HO. We do not have sufficient evidence that the proportion who respond yes to the question. We do have sufficient evidence to suggest that the proportion who responded yes to the question changed. So that's how we do this problem. Take your time and just know that you have to change the denominator in a two-sample z proportion.